So we're going to have a look at introduction to 3G and UMTS, and then we're going to look at network architecture and the AI interface and some aspects of UMTS power control and handover. Obviously, what we're covering in this subject is we're not covering the full aspect of UMTS because of time limitations, and there is a full subject that runs in the spring semester that goes into far more detail in 3G and UMTS. So if you look at the evolution from 2G to 3G, you can see in this diagram that there are two separate paths. There's one path that goes GSM, GPRS Edge, and then UMTS. And this is based on UMTS's AI interface is based on something called wideband CDMA. The other path is based on the original CDMA technology, which is also referred to as IS95A. Now, the corresponding version of IS95A in the packet switch was called IS95B. Okay, and that was a 2.5 generation technology. And this technology in the third generation mobile communication became CDMA 2000. Now, initially they were trying to come up with one mobile standard for 3G, but due to political and other reasons, it was not possible for these two communities to come together and come up with one standard. So you'll find out the Europeans and most of Asia Pacific, Australia, they all adopted the wideband CDMA, whereas in North America and in Japan and even in some of the other countries, CDMA 2000 became the main standard. Now, so there's still a competition between wideband CDMA and CDMA 2000, and now a third technology called WiMAX has become another competing technology for third generation mobile communication, and these three sort of technologies are fighting each other in terms of which is going to become the dominant one. Now, different parts of the world, different countries, and have invested through companies that operate in their countries. They've invested a lot of money in different technologies, so they want their standards to become the stronger one. For example, countries like most of the Scandinavian countries, out of which come Ericsson and Nokia and those kind of companies have invested, and European companies as well. They've invested heavily in wideband CDMA, but the North American companies have they have put a lot of money into CDMA 2000 as well as WiMAX. So whenever you read literature, depending on who's writing it, you see that there is a balance. There is always an argument which technology is better than the other. So the question is, why was there a need for 3G? And that was a question I asked you earlier. So it's based on many factors. Well, second generation mobile networks were very successful. Okay, both GSM as well as CDMA. GSM, in my opinion, is probably slightly more successful than CDMA, but they also had certain limitations. They were able to provide a circuit switch service quite well. So the next question was, how are we going to go to the next generations so that we can continue on with the success of mobile telephony. Now, at about the time when these standards were developed, that was when the internet was becoming very popular. Mid-90s, internet was really beginning to take off, and more and more people were going on the internet, and there was a need. People started thinking, why is it not possible to have the internet on our mobile devices? Okay, now in order to do that, we needed mobile networks to evolve towards a packet switch network. So that was another requirement that was taken into account. And the third reason why we needed third generation was that the data rates on both 2G and 2.5G were very slow, and hence the AI interface on the 2G and 2.5 generation mobile networks was a bottleneck in terms of achieving higher data rates. So what is 3G? So 3G doesn't refer to a specific technology. 3G is essentially a collection of international standards and technologies that are targeted at improving the efficiency, improving the data rate, improving the performance of mobile networks. Okay, so when somebody uses the word 3G, they're not talking about wideband CDMA or CDMA 2000 or WiMAX. They're talking in general. It's a way of going from 2G, trying to look at the problems that we have associated with second generation mobile networks and seeing what can we do to that to improve it. And in terms of 3G, what sort of things will users get out of it? Well, users are going to definitely get greater data speeds. They will be able to have higher capacity for both data as well as voice. And you see the coexistence of both packet switching as well as circuit switching in 3G technologies. Okay, now the fact that these technologies coexist means that there will be, and the fact that we are going to have higher data rates will mean that we can have new applications that can come into the market, applications which found it difficult to get into the market because of the limitations of the air interface in 2G systems. Now, at about the time when people were talking about the need to set up a third generation technology, there was a body called the ITU, International Telecommunication Union, that sort of looked after telecommunications throughout the world. And what this body did, the ITU set up an association called IMT 2000. Okay, so this is around the year 2000, and they said we'll come up with a new framework so that we can develop third generation mobile telecommunication systems. And one of the important things that had to be decided was the fact that whatever 3G technology that you came up with, it had to be compatible with existing 2G systems. Now, this was at the time of this was done in goodwill, the fact that it had to be interoperable with 2G systems, but this also created a lot of problems because, and that was the reason why the sort of a split came about in the development of 3G standards. Now, again, because of the fact that we had so many different standards at that point in time, and it was difficult to bring them together into one future standards, a number of different standards involved. Okay, so actually what happened was IMT 2000 requested proposals for 3G, and a number of organizations submitted proposals. So the main one, the one that we are going to focus in this subject is the UMTS, because that's the one that is relevant to Australia and possibly most of Asia Pacific. But the other one is the CDMA 2000, and the one that has come recently into the 3G space is the WiMAX standard. And again, these three standards, wideband CDMA, CDMA 2000, and WiMAX, there's always a battle between these three. And depending on whom you speak to, each person, whichever camp they're from, they will try to say that their technology is the best technology. So what is UMTS? Well, UMTS was a standard that came out of the European Telecommunication Standards Institute, and it represents the European version of the IMT 2000 family of 3G standards. So a lot of countries, almost all the major telecommunication vendors in Europe decided to come together on this venture, and they came up with the UMTS standards. And here, this standard is now in use in Australia and most of Asia Pacific and almost all of Europe. And also most of Africa will also have also decided to go with the UMTS standard because most of their networks were GSM. So it all depends on what 2G networks you had. Okay, so if a specific operator had gone with a GSM network, then most likely they'll go to UMTS as their 3G network. Whereas if an operator, even in certain countries, there are some operators that went with the GSM, and there are some operators went with the CDMA camp. So those ones with the CDMA camp will most likely evolve to a CDMA 2000 network, whereas those operators who went with the GSM standard will roll out a UMTS-based 3G networks. So these were the main organizations that formed part of something called 3GPP. Okay, so 3GPP stands for Third Generation Partnership Project, and it was a joint venture involving HC in Europe, ARIB TTC in Japan, ANSI in USA, and TTA in South Korea, and the Chinese wireless telecommunications standard. So these were the predominant market players in the telecommunication space, and they all got together and came up with the 3GPP, which in turn came up with the UMTS standard. Now, subsequent to that, the CDMA 2000 group formed their own 3GPP, and they call it 3GPP2. Okay, so again, if you see 3GPP2, it refers to the CDMA 2000 group. So what were the frequency band allocations? Well, obviously, whenever you come up with a new generation, you try and look for frequency bands that are free throughout the world, and you try and allocate those frequency bands for your technology. So the IMT 2000 looked at different parts of the world, looked at Europe, looked at China, looked at Japan and Korea, looked at North America, and said, okay, these are the bands that they're going to reserve for UMTS. So in Europe, it was between around the 1900 bands, and this band was also available in China, so they blocked it in China and in Japan. In North America, there was a problem because these bands were already allocated for PCS. Okay, so this is again another problem that happened, in that the IMT 2000 framework couldn't reserve the 1900 band for in the USA, so they had to use another band in the 1800 space for that purpose. Okay, so where does UMTS fit in? Okay, this part is just a general introduction. Okay, here we have a diagram. I think we've seen this diagram before. On the x-axis, we've got data rates. So as we go in this direction, we're going to high and high data rates. And on the vertical axis, we've got terminal mobility. Okay, so we are moving. We are getting requiring high and high mobility. Now, technology like ISDN and broadband ISDN and ATM and frame relay, those are all fixed line technologies, so they can provide high data rates, but they're essentially fixed in nature. The problem with GSM is that it can provide very high mobility in that space there, but the sort of data rates that you can get out of it is very small. Now with UMTS sort of fits in this area where it can provide a reasonably high data rate and also a quite good mobility, similar mobility to what GSM can provide. So UMTS provides an important area of this mobility versus data rate map compared to some of the other technologies. Eventually, what we want to try and get is, as we go on in time, we want to try and move so that the future mobile broadband systems can sort of come into this area where they can provide both high mobility as well as data rates. Okay, the next thing that we'll have a look at is the architecture of UMTS. Well, just as we have when we saw GSM, we saw a mobile equipment which is connected to the BSS, and the BSS is connected to the NSS. We have a similar concept in UMTS as well. So now we have replaced mobile equipment by something called user equipment, because again, because it's using a different air interface technology, and also it's a far more sophisticated device than the GSM handset. The UTRAN, or the UMTS terrestrial radio access network, is the block in the middle, and that is equivalent to the BSS that you saw in GSM. And then the core network is the core network that was already in GSM and GP. If you look at GSM and GPRS, all of the elements that we had in the core network of GSM and GPRS evolve into the core network of UMTS. So essentially there are three components: the UMTS terrestrial radio access network that provides connectivity between the user equipment and core network. The core network is where all the services are located. Okay, so essentially the user equipment is trying to access services that are available in the core network. And in order to achieve this connectivity, they've got to go through the UTRAN. The core network is the one that does all of the functions such as switching, routing, charging. All of those are provided in the core network. So we saw in GPRS that we had to establish a separate packet core network that does things like routing, a separate form of charging, and so forth. And we also know from GSM that the core network in GSM, which was called NSS, it had to provide stuff like switching, access to database, authentication, and all of those functions were provided by the core network in GSM. This diagram is from the HC technical specification, so if you want to know more about it, you can go to the internet and download the specification from the internet. And it has a diagram showing all the different interfaces. Now, we already saw this path here when we looked at GPRS. We saw this path, how users are connected through the BSS to the SGSN, GGSN, out to the packet data network in the GPRS world, and through the MSC VLR to the PSTN network. Okay, now the new elements that we are introducing here are these ones here. Okay, so here we've got the terminal equipment and mobile terminal forming the user equipment, and the user equipment going through the wideband CDMA air interface, which is called the UU interface, to the UTRAN, and from the UTRAN it can either go through the RU interface to the MSC, or it can go through the RU interface to the SGSN. So these are the new network elements that have been introduced as a result of going to the 3G network. Okay, so it requires a new UTRAN, which means new base stations, and it also means new handsets and so forth. And these interfaces here are some of the new interfaces. So UU is a new interface, RU is a new interface, and so forth. Okay, this is a very simplified diagram. A diagram that is more representative of what's happening would be something that looks like this. Okay. So here we go back to that same diagram that we saw earlier, and here we have our user equipment at the bottom. You have our UTRAN here, and here you have our core network. The core network, you can see most of the core network is inherited from GSM GPRS. So the same network elements that you saw in GSM are there, like MSC, VLR, HLR, and so forth. And the network elements from GPRS, which are SGSN, GGSN, those network elements and those network interfaces are inherited from the GPRS world. The thing that is different is this UTRAN. So in the UTRAN now, we have new base stations Okay, so these are all new base stations called node Bs. Okay, so instead of calling them BTS now, we refer to them as node Bs. And we've also replaced the BSCs by something called RNC, or Radio Network Controller. So the Radio Network Controller essentially controls a number of node Bs. Now, one of the thing that we have new here is this interface here called the IUR interface. Okay, before we never had this situation where BSCs were connected directly to each other. BSCs always interacted through the MSC by going up to the MSC and back to another BSC. So now we've incorporated a new interface called IUR interface, and this is very important for UMTS network, because as a result of this we can now perform things like soft handover, and we can also perform something called macro diversity. Okay, all of these are possible only because of the fact that this new IUR interface has been implemented between RNCs. Okay, now the RNC also has to communicate with the packet switched and the circuit switched network, and it has an interface here called the RU interface. So this RU interface is referred to as the RUPS, because it's the RU interface that communicates with the packet switch network, and this RU interface here is referred to as the RUCS, because that's the part of the RU interface that interacts with the circuit switch network. And you also have a third interface called RUB interface, and that's the interface to the base station or the node B. Okay, so you can see that just as in GPRS, most of the interfaces started with the letter G. In the new interfaces that were specified in the 3G or UMTS network, these were referred by the letter I. Okay, so you have IUPS, IUCS, IUB, and IUR. Okay. Now another thing that also took place is that they decided to use ATM. So a very important change that took place in the UTRAN was that they tried to convert all of the information into ATM cells, and ATM cells was the means of the transport technology. Okay, now you might ask yourself, why ATM? Okay, so that's a very important question. Asking yourself why should have ATM be used as a transport technology in 3G UMTS network? Okay, there are certain properties that ATM had which most of the other technologies didn't have at that point in time. Okay, so you can see that all the bits that I've shown in red here are the new ones that were added to roll out a UMTS network. Okay, again, same diagram but redrawn sideways, and this is from a source called Alex Cooper, and I'm not sure if his slides are still on the internet. So if you search by Alex Cooper, you might find his slides are still there. If they're not, you have to use the ones that are provided here. But this is a good diagram. Again, this shows, the top part shows the GSM network with the BTS and the BSC and the MSC VLR, the GMSC out to the PSTN network, and then all of the databases that you can have, HLR, Authentication Center, EIR, and then there are also other value-added services like WAP and so forth. Now this was in the circuit switch domain, and then we added these elements here. These packet switched elements were added with GPRS, and now what we have done is we've added the node B and the RNC, and then we've incorporated the new interfaces, like that interface there is the RUPS interface, and that interface there is the RUCS interface, and so forth. So this is referred to, this was the first, in 3G, this was the first release. Okay, so this took place in 1999. Okay, and that's why it's referred to as a Release 99 architecture. Okay, some people refer to it as Release 3. Okay, it came the year it came out was around 1999. So what was new in Release 99? Well, it was the first phase of UMTS. The air interface, new air interface. So this air interface here was based on wideband CDMA, and it also allowed coexistence of GSM, GPRS, and UMTS on almost the same infrastructure. The new elements were the Node B, the RNC, and obviously the handsets. Now, the next release, the release that came after the Release 99, was try to see how can we make it better. How can we make the Release 99 better? And this was called Release 4. And I think most of the operators have now moved to Release 4, as far as I'm aware. Maybe some operators are still in Release 99. Now, this was done by leaving your RNC and Node B and the SGSN and GGSN alone, but just by making changes in this part of your domain. In the circuit switch domain, what they did was they added something called a media gateway and an MSC server. So the MSC evolved to become something called an MSC server and a media gateway. A media gateway was essentially a glorified ATM switch. And all of the traffic from the RNC, all of the circuit switch traffic went through the two media gateways out to the PSTN network. The MSC server, so the MSC's function was split. There was a separation of the connection function and the control function. The connection function, the MSC server essentially establishes the connection between the RNC and the external network, and once it establishes that connection, the MSC, essentially what we are doing is we are separating the data traffic as well as the control functions. So the MSC server performs all of the control related functions, and as far as connection, as far as the ATM cells that are coming out of the RNC to a circuit switch network go through the media gateway and out to the PSTN network. Okay, because one of the problems we were sort of facing with the historic MSC was that the MSC was processing every time slot that was going through it, and as a result of that, it was getting the performance of the MSC was becoming considerably affected. So by separating the data transfer as well as the control functions, we were able to get better performance out of an architecture like this. The other thing that was also added is this thing called IMS. Okay, so the IMS enabled integration of voice over IP calls as well as multimedia calls on one network. And what's going to happen in the future, and I have a feeling that some operators have already moved to this setup, and this is called Release 5. And what's going to happen in Release 5 is that, what do you see in Release 5? If you compare it with Release 4, everything is IP. Okay, so there's no more circuit switch network. This entire circuit switch domain is removed and replaced by a packet switch domain, and that is happening already in our PSTN network. Even the PSTN network that we know now, eventually all of the circuit switch technology in the public switch telephone network is going to be removed and replaced by packet switch technology. So Release 5, this is a vision slide that 3GPP Release 5 vision slide, and that everything, so from the user, okay, from the user, everything will be transmitted in the form of IP packets across the air interface, between the BTS and the BSC, everything, all the way from the source to the destination, will be in the form of IP packets. Okay, so again, a good question is knowing the difference between release 99, release 4, and release 5. Most likely in the next couple of years, all of the operators will be in release 5. Okay, now the other network components, the user equipment is again made up of the USIM. The SIM card in the UMTS network is a far more sophisticated version of the SIM card that you had in the GSM network, although it's backward compatible. So if you take a UMTS SIM card, it will work on a GSM handset, but not vice versa. Okay, and so the USIM card has more features in it. Okay, better security. It has more information, higher processing. It can even, in terms of data fields, it can store like in 2 languages and so forth. The terminal equipment and the mobile terminal are also different, and we're going to look at each one of these in detail. So let's just, the user equipment is again made up of the mobile equipment, USIM, and an external device such as a terminal equipment, a laptop that you can connect to your mobile. So the user equipment is made up of these 3 parts, and it's connected to the UTRAN. The UTRAN is probably the most complex part of the 3G network, and we've already seen that the UTRAN is made up of RNCs, and these RNCs are connected to each other through the IUR interface, and these RNCs connect to the base stations using the IUB interface, and you've got the IUCS and IUPS that go out of the RNC to the core network. So the node B, which is the base station, is probably one of the most important devices. It's the node B is equivalent to the base station in GSM, and this is the one that performs all of the radio transmission. So both the radio transmission as well as the reception has to be performed by the node B, and whatever information is coming on the A interface, they've got to be converted into ATM cells and transmitted on the IUB interface to the RNC, and that function has to be performed by the node B. So the node B becomes the first element that starts putting the IP packets that it is receiving from the IP packets or the voice that is receiving from the mobile into ATM cells for transmission to the RNC. Okay, so the node B has to communicate across the A interface to the user equipment, and it has also got to communicate on the IUB interface to the RNC. What are the functions it has to perform? Well, error correction. Okay, almost all base stations, whatever the technology is, this is where information first arrives across the interface. So all of the error correction functions have to be performed at the base stations, just as in the GSM case. Rate adaptation, okay, we'll talk about rate adaptation later. Basically, in UMTS, you've got a set of standard data rates at which you're allowed to transmit data because of the fact that you use something called a code tree in UMTS. So if the data rate is below one of these well-specified code rates, then you've got to adjust the code rate by adding extra bits to the data so it comes into one of these standardized data rates. Again, when we'll have a look at the code tree, we'll see what are the possible data rates that we can achieve. We've already seen the concept of spreading and despreading. When we looked at media access control, we saw that in direct sequence spreading, we multiply the data signal by something called a chipping sequence, and that increases the data rate of the signal. So this spreading function has to be done at the base station when it transmits it on the downlink, and whatever information it receives on the uplink from the user equipment has to be despread with chipping sequence. Also, before you transmit, you've got to modulate your signal, and the Node B, the UMTS standard makes use of QPSK modulation as a modulation scheme of choice for downlink transmission. Another thing that happens is handover. Okay, so when users are moving from one cell to another cell, you have handover taking place. But handovers could also take place if a base station has many sectors. Okay, we've come across the concept of sectors when we looked at cellular networks. A base station could have many sectors. And if a user is moving from one sector to another sector within the same node B, you have a handover taking place. Okay, and that is referred to as a softer handover. Okay, so in one of the things you will find out in UMTS is that there are many different types of handovers. There's handover called hard handover, there's a handover called soft handover, and there's a third type of handover which is referred to as softer handover. And softer handover takes place within a node B when a user moves from one sector to another sector in the same base station. Another thing that also takes place is called macro diversity in UMTS, and I told you when we were discussing the IUR interface, one of the important functions of the IUR interface is that it enables macro diversity, because in UMTS user equipment can be communicating with two different node Bs or two different base stations at the same time. Okay, and because it's communicating with two different base stations at the same time, the information that is sent to the two node Bs have to eventually come back to the same RNC. And that RNC compares the information that it is receiving via two different paths, and then it selects the best data on a frame by frame basis. Okay, and that is called macro diversity. And it could happen that for few milliseconds, one path is obstructed due to shadowing or some other propagation phenomena, in which case it will select the signal that is coming from the other path. So essentially, macro diversity gives UMTS a much better performance than in GSM. In GSM, each mobile is only communicating with one base station at any one time. Okay, so if that signal was to drop due to shadowing or some other propagation phenomena, then you see that your quality drops straight away, the quality of your communication. Whereas in UMTS, because every user has the capability to talk with up to 3 base stations at the same time, and if all of these signals from these 3 base stations go back to the same RNC, the RNC can then detect which is the best signal and it can do this on a frame by frame basis. So, that process is taking place rapidly. So macro diversity is another thing that is possible, and when you have when the cells are in the same node B, then the macro diversity function can be performed by the node B itself. The node B has to take measurements. Okay, every device in a mobile network, whether it be the mobile equipment or the base stations, has to take measurements. The node B takes measurement of uplink signals, and it takes measurements of the signal quality, the frame error rate, and so forth, and it reports these measurements to the RNC. Similarly, the user equipment is also taking measurements, and the user equipment is taking measurements of the downlink. Okay, so again, very important that downlink measurements are taken by the user equipment, uplink measurements are done by the node B. And all of these measurements that are taken by all of these devices are then reported back to the RNC, and the RNC then makes a decision as to which link it should use, because it has essentially, basically what it has is it has real-time information about the performance of various transmission links. Another thing that the node B has to do is power control. Now remember, when we talked about this concept in the third lecture in media access control, we talked about the near-far effect. Okay, and this is very important in CDMA networks, because in CDMA networks you've got to make sure that the transmission that is received from different user equipments has to be of the same power when it arrives at the base stations. And in order to do that, you've got to perform power control very precisely in UMTS networks. Okay, so again, very important question: why is power control so important in UMTS networks? The next element that we're going to look at is RNC. Okay, so we've just seen that the Node B performs a lot of information, sends a lot of information to the RNC. So the RNC is equivalent to the BSC that we saw in GSM, but it's far more complicated. Okay, it's almost of the order of 10 magnitude complexity compared to the BSC that we saw in the GSM network. What are the functions that the RNC does? Well, it's got to all of the resources that the Node B provides, all of the radio resources that the Node B provides to its users, the control of those radio resources have to be performed by Node B. So these, and it's also have to do layer 2. When you're talking about layer 2 processing of user data, you're talking about the transmission technology. Okay, so ATM cells, when they come in, okay, it's got to decide, okay, is this particular ATM cell, is it got to go to the circuit switch network, or is it got to go to the packet switch network? And in ATM, every time an ATM cell goes into an ATM node, there's a lot of processing that has to take place. Not as much as an IP, but there is still some processing that needs to be taking place. So all of that has to be done by the RNC. And then it's got to do 5 important functions associated with radio resource management. And the first one, and the most important one, is power control, okay, handover control, admission control, code allocation, and packet scheduling, and macro diversity. Okay, we've already talked about macro diversity, the fact that you've got multiple paths coming through from multiple BTSs to the RNC, and it has to take the best connection. Packet scheduling, okay, how should packets be scheduled for transmission on the downlink? Obviously, if you have real-time packets and non-real-time packets, you want to give high priority to real-time packets because of the time-critical nature of real-time packets. Whereas non-real-time information can be delayed a little bit. Code allocation, we'll talk about code allocation and the code tree when we talk in the air interface, but essentially every user has to be allocated a code, and that function has to be performed by the node, the RNC. Admission control takes place when a user wants to use the network. They do a PDP context activation or they dial a number. Then the network has to decide, do we admit this user or not? Because remember, in UMTS, everybody is transmitting at the same time and on the same frequency. So everyone's transmission is interference for the others. And if the interference goes above a certain maximum possible interference, then you don't admit any more users into the network. So that function is referred to as the admission control. Handover, we've talked about handover a little bit, and power control. Power control and handover will focus a little bit more towards the end of this lecture. Okay, so again, a table with the differences between the functions of Node B and RNC is a good question. The core network elements are the same as in what we've seen in GSM and GPRS. So again, we're not going to spend a lot of time with this one. Okay, now when we come back after the break, we'll have a look at the